Welcome back everyone to the Hello World guy, and in this video we are going to set up the build system for our project. So when it comes to build systems in C++, there are many options. However, the industry standard for build system is the CMake build system, and that is what we'll use in this project. So the CMake build system isn't exactly a build system on its own, but instead it is a build system generator. What that means is that we specify our project using CMake's own language, and then CMake generates files for another build system like Make files or Ninja or Visual Studio project files, and then we use that to actually build our project. The advantage of this approach is that it is first of all more scalable, since we don't have to write clunky build system files or configure settings in like an IDE, and all of that can be generated by CMake, and we can write our stuff in a higher level language. And secondly, it's also more portable, since CMake can easily generate project files for various different platforms, so it's better than writing raw make files or using an IDE's project files. Now there are alternatives to CMake that are also build system generators like it, which generate files for another build system, and those have their advantages and disadvantages as well. But CMake, as I said, is pretty much the industry standard for C++, so that is what we are going to be using in this series. Alright, so I've got this empty folder opened up now, and here we are going to start setting up our build system. And before we get started, you should have a CMake installed, of course, and you can install it quite easily from the website. And you should also have an actual build system installed like Visual Studio on Windows, and on Linux you should have something like Makefiles or Ninja installed. So to get started, we are going to create a file called CMake lists.txt. Now this is the file which CMake will read, and it will describe how our project should be compiled and its dependencies, etc. And the name of the file must exactly match this. So if you create that, your IDE should recognize that it is a CMake file, and you should get appropriate syntax highlighting, etc. if your IDE supports it. So now how are we going to get started writing this? So this is our top level CMake files, which means that CMake list.txt file, which means that this describes our whole project. And then later we can also add like subdirectories and have sub projects in the project, but currently we are of course not going to have only one. So the first thing that we need to do is we need to use this function or command called CMake minimum required, and this will use to specify which version of CMake we must the minimum version of CMake that must be present, and a good default is version 3.2. so we are going to set that as our minimum version. And since this is the top level CMake file, we are also going to have to specify the name of the project. So for that we can just say project, and in here we can put the name of the project. I'm going to just say SFML3 tutorial. Alright, so with that we have got this setup, but currently of course we don't have any executables or libraries in here. So in CMake we can of course add libraries as well, static libraries, dynamic libraries, as well as executables. Currently we are going to just keep things simple, and since our project is just in one executable, it's going to be in one executable, so we can use for that the add executable function here. And what this does is that it allows us to basically add an executable to our build setup. So first of all we can specify the name of the executable, and this name will be basically our target. So what that means is that when we want to change different things about it, add link libraries to this executable, we'll use the name that we'll specify here. So I'm going to just say SFML3 tutorial here as well, and this is the name of the target. And after that, the next thing we need to specify is the files that it will have. So in here I'm going to actually create a folder called source, and here we'll add all of our source files. And here we will create a file called main.cc, and this will be our main file. So now in here we can just specify each of the files that we want. Ahead of this we can just say source/main.cc because currently we only have one file, and that will add our executable target basically. And while this basically sets up our project, we can go ahead and set some other things as well which might be important. First of all, we are going to set the standard that we want. So for that we are going to use this set function, and we can give it the variable or the thing that we need to set, which is CMake CXS standard, which is the C++ standard, and let's just go with the latest and greatest. So we're gonna say CMake standard is equal to 23, and then we also need to set required. So this will we need to set this to on, and this ensures that the CMake standard is actually required. So otherwise it will, if the C++23 standard is not available, it will fall back to an older one, which is not what we want. So we need to set that to be required. And another thing I like to do is that we can go ahead and CMake CXS extensions, and I'm going to turn that off so that we don't get any non-standard extensions here by default. So yeah, that works, and we have added our executable, and yeah, that should basically work. So if I go ahead and actually try to build this, well, currently of course it won't build because we have got our main.cc is empty, but I'm going to just add an empty main function here. So after that, to actually build this, we can create a new directory called build, and we can go under that directory, and we can actually do this from outside as well. We can run CMake, and we can give it the B option, the capital B option for our build directory. We are going to say build here, and then we are going to give it our source directory with S option, and which is the current directory. And then we can set some other things. Mainly we are going to say that the G option, which selects the generator. Now you can use the default generator. On Windows it will be Visual Studio, on Linux it will usually be Makefiles, but we are going to set the generator to Ninja because that is usually faster than Makefiles. So we are going to say G Ninja here. You can of course just use Makefiles as well without specifying this, or you can if you're on Windows, you can also use Visual Studio project files. And this build directory, by the way, is important so that we actually don't pollute our main directory with things that we don't want. And we can set additional variables here as well with the D or the define command. We are going to only set one, which is CMake export compile commands. This is because we are using clang D here in my setup. I'm using that, so I want to actually, this will generate compile commands .json for clang D so that it can actually give correct IDE information according to our project setup. So we are going to set that to 1. Now if I go ahead and run that, you can see that it does some things, and it says that build files has been written to this directory. Now if I look at the build directory, if we go here and look at the build directory, you can see it consists of a bunch of CMake cache, CMake files, as well as a CMake cache.txt, but more importantly it contains a build.ninja files. Apart from that, it also has our compile commands.json here. Now this build.ninja is what we'll use to actually build it, and if you were using Makefiles, it will generate a Makefile here, etc. So to run this, we can actually go under build, and we can just run Ninja as well, but we can let CMake do that for us by using CMake and using the build option, and this tells CMake to actually build using whatever build system it generated, and we can pass it our build directory. And then we can go ahead and give it parallel as well, which means it's going to run it in parallel instead of doing it sequentially, so that it's faster. And if we go ahead and press that, you can see that it did that, and it linked the executable as well. Now in this build here, you can see that we have got our SFML tutorial here, and if I go ahead and do ./build/SFML tutorial, nothing happens, but that did compile. So yeah, we have got our basic build system up and running. Now of course, writing these commands each time will not be very interesting, so let's go ahead and make a build script here called build.sh, and this we are going to just use this to basically run the command for actually building our project. So we can go ahead and build b.s actually B is going to be build and S is going to be the current directory, and we can go ahead and say G Ninja and D CMake export compile commands equals 1. And to actually build this, we can run CMake build in our build directory, and we can run that in parallel. And I'm going to set the number of processes to the number of cores of the CPU. So if I go ahead and run .build.sh right now, well, of course, first of all, let's make that actually executable. And secondly, let's remove our build folder so that we can do it again. And let's go ahead and run build again now, and you can see that it works. And if I go ahead and run build/ SFML3 tutorial. That does nothing, but it does compile. So let's go ahead and also add a run.sh file here, and we are going to add our bin/bash here, and then we are going to set e, so that if any command fails, then it is going to stop the script. Then we will run our build command. First of all, we'll run the build script, and after that we are going to run our actual executable, so build/sfml3 tutorial. So if I go ahead and run, well, first of all, let's remove that, and then we can run this. Actually, we need to make this executable, and now if I run this script, you can see that works. And of course, you don't really need these scripts if you are on Windows and you generate your Visual Studio project files. Then you can just use them as is, and it should not cause any problems. Yeah, that is basically working, and I'm going to just restart my LSP here. And now let's see if since we set the CMake standard to 23, we should have C++23 headers here. So we can use that to see if our compile commands are working. So let's try including print, and you can see that does work. And let's use std print line, and let's say hello world, and see if that compiles and runs correctly. And you can see that it does compile and it does run correctly. So yeah, with that we have got our basic CMake setup working quite nicely. Alright guys, so this is going to be pretty much it for this video, and in this video we have got our build system set up, and in the next video we'll add the actual SFML library dependency to our project, and then we'll get started with actually using SFML3. So yeah, make sure to like and subscribe so you don't miss that one, and share this video with other people as well, and I'll see you in the next one, and bye.